Welcome back, guys. Today is the second DILR video. We have our question here. Let's start with it. A string of three English letters is formed as per the following rules. So we have three letter string or a word. Let's read the condition. The third letter is any vowel. So it can be A or E or I or O or U. The third letter. The first letter is either X or Y or Z. Okay, X or Y or Z. If the first letter is Z, so now they have come to conditions. We see 3, 4, and 5. All the rules are if the first letter is X, Y, or Z. So it's better that we start writing the conditions individually. The first letter is X, Y, or Z. Let's see what the conditions have in store for us. Now, if the first letter is Z, the second letter is A or E. Okay. So this can either be A or E. Now if the first letter is Y, the second letter is the same as the third. So let the letter be, since last letter are vowels, I'll consider this a set of V. It's just for notation, don't worry. So if it is V1, then again this should be same. Any from these vowels must come here. That means the same letter will also come at the second place. And the last is if the first letter is X, the second letter is a vowel different from the third letter. So if this is V1, this is V2, where V2 not equals V1. This is just denotation, so don't worry about it. Now we have these conditions. Let's go to the questions. Find the number of strings which can be formed using these rules given. So what can we say? Let's look it by condition. We'll name it first, second, and third. So in the first condition, the first place is fixed. We have only one way, and at the second place and at the third place. So if we take one vowel at the third place, suppose A, so we are picking it out of 5, right? So it's basically 5C1. Now how many vowels remain for us? Can we take it 5 or should we take it 4? Since we know V2 is not equals to V1, this will not be equal to V1, so we cannot repeat the letter. So now the set reduces itself from 5 to 4, and that we can pick up from the remaining 4 vowels. So the total becomes, this is 4, this is 5, and this is 1, becomes 20. Now the second condition, for the first letter there's only one way, that is Y, and the second letter and the third letter must be same. How can it be same? Is there any way we can choose for it to be same? There's only one way for it to be same, or is there multiple? Think about it until then we'll write the third condition. Z can only be once, A or E. So basically out of 2 we are picking 1. And does the condition for Z say anything about the third letter? If the first letter is Z, the second letter is A or E. No, they do not say anything about the third letter. So we can have any vowel from the set. Now here it becomes 2 into 5 into 1, that is 10. Now think about it. Can there be any way where both of these are different? No, right? So if I choose any one from here, that same letter will repeat at the last, or vice versa. If I choose any one for the third place, it will repeat at the second. So I choose 1 out of 5, and the same letter I'm gonna repeat here again. So it's basically 1 into 5 into 1, that is 5, and the total becomes 35. Let's see if there's an option 35. Yes, there is, so we'll take it. Coming to question number 2, what is the number of strings that can be formed which have 3 distinct letters? So in condition 2, we already know the 2 letters are repeated, second and third, so this goes out of the picture. So we remove 5 from the total, right? Now in condition 1 and condition 3, let's see how many letters are there actually. X, V2 and V1, they have specified that V1 is not equals to V2, so basically all 3 are distinct characters, so all 20 would be there. Now coming to Z, A and E, let's write sub conditions for Z, A and E. one which has Z and A as starting, the other which has Z and E as starting. Now the third letter could be anything. It could be Z A A, Z A E, Z E A I, Z A O, Z A U, and similarly. All the other letters apart from A make this a distinct combination. If I take A, it is the only condition where two characters are identical. So basically we are removing A. And same case here, if we have to take A, E, I, O and U, there's E which is making it a repeated character, so we remove E. Other than that, all the 4 cases here and 4 cases here are distinct. So in Z, not all the 10 cases but 8 cases. Here 0 cases, and for Y, for X, all the 20 cases. So 20 plus 8 gives us 28. Let's see if there's it's a theta question, so that answer is 28. I hope it was clear. Now the third question. For two strings S1 and S2, the second letter of S1 is the same as the third letter of S2, and the third letter of S1 is the same as the second letter of S2. Okay, let's stop here. So let's assume S1 and S2. 1, 2 and 3, 1, 2 and 3, right? If the first letter of S1 is Z and the first letter of S2 is X, that's what the question said. S1 has Z as the first letter and S2 has X. And the alternates 2 and 3 here and 2 and 3 here are same. So let's assume this to be V1 and V1, this to be V2 and V2. Alright. Now what is the condition for Z? Z must have A or E, right? So V1 can either be A or E. That means here also it can either be A or E. Now what are the conditions for V2? For that we'll have to check X, because Z does not say anything about the third. So we go to X. It says that the second character is definitely not the third character. So it can not be A if V1 is A, and it cannot be E if V1 is E. So how do we write this condition? Let's simplify it. Z A and something, so X A and something. This is the first condition. The second one is the second one is Z E dash and X dash E. I hope you understand this. So now how many options does X have here? Other than A, he can have all the 4 vowels. So we can write we have 4 ways and we have 4 ways, because Z doesn't have conditions. So totally this string 1 and string 2 have 4 different ways, with A as second position in Z and third position in X. Similarly, if we have E, we can still have 4 here and 4 here, A O I U and A O I U. So this gives us 4. So a total is 8. Let's see if there's an option 8. Yes, there is an 8. The last question is, find the number of strings which can be formed such that the second letter of string is E. Okay. The second letter needs to be E. Here we can have any 3 letter, right? First let's go back to this. Here how many cases can be there? Z had total 10 cases, so half of it would be A and half of it would be E. So we need second letter to be E, so we take 5 of E and we remove 5 of A. So from Z as the first character we have 5 words or 5 strings. Here there is only one way possible where the second letter can be E for Y, because we need the third letter as same as the second letter. So if we put E here, we need to put E here. There's no other way. So we have one from here. Now how many conditions are possible here, where if V2 becomes E, what values can v1 have? It can have any other value than e, right? So it can have a, o, I, or u. That means 4. You understand? If we put e here, we have 4 other values, so we have 4 different combinations. So 4 plus 1 plus 5, that gives us 10, and the answer would be 10. Thank you.